Hi students, in this video we're going to look at how to solve logarithmic equations. Right, so after watching this video you should be able to use your log laws to simplify logarithmic expressions, and then once those logarithmic expressions have been simplified we can then solve logarithmic equations. Alright, so a few things to recall. So remember your log laws, how we use them to simplify expressions. So our rules for adding logs, we multiply our values. When subtracting logs, we'll divide our values. Those will be the main ones that we use. And another thing to recall is that the value of an exponential expression with positive base must be positive. So for example, if we've got 2y equals 2 to the x, then that means that value of y must be greater than 0. Because the same sort of idea is true for logs as well. If we have log base 2y equaling x, then our value here must also be greater than 0. Alright, so our steps for solving logarithmic equations. Our first step is to set the domain. So as already stated, if we've got log of some positive base b equaling our value x, then our value x must be positive. That sets a limit on what is possible in terms of our solutions, as not all values may actually be used in solving our logarithmic equation. Our second step is to simplify each side of the equation, so there is a maximum of one logarithmic term on each side of the equation. Alright, now once we've done that, if there's one logarithmic term on both sides, then we can equate those values, right, in the same way that we could equate the values of 2 to the x equaling 2 cubed. We could just equate the powers and say x must equal 3. We can do the same sort of thing with logs if there is one log term on both sides. If there's only one side of the equation with a logarithmic term, then we can rewrite the equation using our logarithmic definition. That is, if log base b of x equals y, then x equals b to the power of y. Once we've done that, we can solve for our unknown. And then our final step is always to check for our reasonableness by making sure our solution or solutions are in our domain. So being able to get that domain set up early is a very important step. Alright, so let's solve a couple of logarithmic equations. An easy one to start off with, we've got log 3x equals 5. We can just go straight to our rewriting step. So that means x is the same as base 3 to the power 5, and 3 to the power 5 is 81 times 3, which is 243. All right, so there's our first one solved, just doing our simple rewrite, knowing that our log can turn into our exponential equation quite easily. All right, our second one, we've got log x plus 8 minus log x equals log 3. So our first step, we should probably set our domain here. We didn't really in the first one because it was such a simple sort of problem. For this second one where we've got multiple logs, setting our domain will be very helpful. So first of all, we know x plus 8 must be positive, it must be greater than 0. So x is greater than negative 8. And we also must know x is greater than 0. Now looking at both of these inequalities, this second one basically covers both. So if x is greater than negative 8 and x is greater than 0, then realistically x just has to be greater than 0, because if it's greater than 0, it's also greater than negative 8. So we can just consider this part here, this x is greater than 0 inequality. That's our domain. All right, so looking at solving this, we can say log, we can use our log law here. So subtracting our logs means we can divide our values. Now that we've got one log on each side, we can equate our values. X plus 8 over x equals 3. X plus 8 equals 3x. Okay, let's go up here. 8 equals 2x. X must equal 4. And there's our solution. Quite simple there. Logs on both sides means we can just equate our values once we've done a bit of simplifying. All right, our last one. We've got log base 2x minus 2 plus log base 2x equals 3. Now, setting our domain, x minus 2 must be greater than 0. So that means x must be greater than 2. And looking at this second term, x must be greater than 0. The one bit of our domain we can take as true to cover both situations is that first one, because if x is bigger than 2, then it's definitely bigger than 0. So we'll just take that first inequality there, and that's our domain. Our answer must be greater than 2. All right, so applying our log laws, we're adding in this case, so we can multiply those. So log x times x minus 2 equals 3. And now that's log base 2. All right, now we've got a log on one side, so we can rearrange that to say x, our value, x times x minus 2 equals our base 2 to the power of 3. And now this looks like an equation we can solve. We might have to expand this. So x squared minus 2x equals 8. And then rearranging that, we've got x squared, well, we've got a quadratic here. As we can see, we've got x squared, quadratic. So to solve our quadratic, we'll just rearrange so one side equals 0. Right, we can then factorize that one. So our two numbers will be negative 4 times 2 gives negative 8. Negative 4 plus 2 gives negative 2. So we can factorize that to x minus 4, x plus 2. Final factor law, x must equal 4 or x must equal negative 2. Right. So really the step before that should say x minus 4 equals 0 or x plus 2 equals 0. And then we can say x equals 4, x equals negative 2. Now going back to our domain, we said x is greater than 2. So therefore, x equals 4 is the only solution, as x must be greater than 2. And so there's our solution to that particular log problem. Our x value, once again, has to be 4. And it can't be negative 2 because it doesn't fit in our domain. All right, so after watching this video, you should be able to apply log laws to simplify logarithmic expressions. And then once they're simplified, solve logarithmic equations.